Today, what I want to talk to you about are kind of some practical considerations. When I've gotten on stage in the past, we've talked about the benefits of immersion mining. The beautiful thing about that is I don't have to talk about those benefits anymore. All you have to do is walk around the show and you'll see that everyone is doing immersion mining. When I started doing this 7 years ago, and I told people I was going to be putting miners in fluid, I was getting blank stares and people wondering when I stuck my hand in the fluid if I was going to die. Well, nowadays we know that we have millions, literally millions of devices in fluid. So let's talk about some of the practical considerations, things that you got to think about before you start planning your immersion mining. And let's just do a little update in terms of what we do. So we are Engineered Fluids. You can find us on the web at www.engineeredfluids.com. We've been manufacturing dielectric coolants for multiple industries, including the crypto industry, for over 7 years. So what's new for us in 2022? So we've moved our research and development lab from San Francisco to St. Petersburg, Florida. Got to tell you, right? Round of applause. Thank you. Yeah, it was a great move. Taxes are fantastic in Florida, particularly if you come from California. So that was a really good one. In addition, we bought a brand new facility in Tyler, Texas, and are going to be increasing our current production of dielectric fluid. You know, I remember 7 years ago when we started, we were excited when we got an order for like 200 liters. Now we are regularly shipping tanker trucks filled of 25,000 liters of BitCool and more to multiple customers around the U.S., to the point now where we're actually increasing our production quite substantially. Today we can do about 1.5 million liters of BitCool, AmpCool, and ElectriCool. And on our new facility, we're going to be looking at expanding that to over 2.5 million liters a week. We are also buying our own tankers and expanding our delivery capabilities, as well as all of our raw material storage. Unlike a lot of things right now in the economy, we have not had to dramatically increase the price of our products. And the reason for that is that we made a lot of substantial raw material investments early in this cycle to make sure that we could deliver product for our customers without having to negotiate new delivery, new pricing, and things like that that's affecting everybody else in the supply chain. The other thing that we added was really something that was frustrating to me, which was we obviously, in order to do immersion cooling, need dry coolers. And if anybody has tried to purchase a dry cooler or an EC fan motor these days, you know that delivery times are out in the multi-48, 60-week time frame. So we actually sat down and redesigned and optimized a set of dry coolers ranging in size from 175 kW up to 1.5 megawatt, and are producing those locally with all US manufactured components right here in Florida, and are able to deliver those in about 14 to 15 weeks, depending on the size of the unit. So for us, this took a giant chunk out of the supply chain challenge, particularly if you were trying to import them from China or from overseas, and we're dealing with a lot of the importation challenges at Long Beach and all the other ports in the US. So these we're able to truck directly anywhere within North America. We're in fact now shipping these to our manufacturing facility that we've created down in South Africa as well. I think one of the areas that we're most proud of right now is we've expanded our total reach. We now have over 1.72 million devices immersed in our fluids globally. We believe that's the largest number of immersed devices functioning, and many of those devices have been in fluid now for more than 3 years. We have a number of devices that have been functioning at 100% capacity for over 7 years without a failure. So, you know, I think that's a real tribute to Dr. Dave, our chief scientist and chemist who invented our products. He's done an amazing job. In addition, as part of our expansion, we've added manufacturing capability now in South Africa, and we're about to launch our Saudi Arabian venture as well. We already have direct sales through Europe, through our office in the Netherlands, and we're adding distributors throughout China, Taiwan, and Australia. So from a growth perspective, we see immersion as on the obviously on the tear, as things have gotten more challenging in terms of actual mining, one of the things that we see is that immersion is a great solution, right? You get more bang for your buck, you get your miners lasting longer, and you can oftentimes reduce the number of miners through overclocking. And I'm going to talk about the practical considerations of overclocking in a little bit here. Here we go. So I want to talk about some of the practical things that we see, the challenges when we're working with some of our larger customers about how to do this in a way that not is just profitable day one, but is profitable over the lifetime of the systems that you're building and designing. So the first one is we have a lot of folks who come to us and say, hey, I've got 2 megawatts, I want an immersion system. And that's fantastic. And then they've planned all of that electricity for the mine, but nothing for the other considerations, things like pumps, dry coolers, network devices, system losses. So you really need to take a full look at what your power needs are before you go out and start buying all these very expensive transformers, right? Because oftentimes we can work with you to either optimize around a specific voltage that you may have. In other words, if you're going to be doing all 415, we can go out and find motors that will work for pumps and dry coolers using 415, or we can use 480. Why 480? Well, one of the best things about 480 is it reduces your copper cost when you're out there building your mine. You're going to spend substantially less money on the infrastructure because you're not going to be buying big wire. Also, it's a standard voltage available in North America. Obviously, if you're in a different part of the world, then we'll focus on what you have there. But please, think about what you're going to put in the mine beyond the miners, and let us help you design your immersion mine so that it takes into account all of those considerations so we get it right the first time. The other one is the impact of overclocking. Now, a lot of us know and have done a lot of work around overclocking, but what we don't think about is well, what's the impact on the ambient air temp? Meaning, how much more heat am I going to generate when I overclock? How much do I have to oversize my dry cooler? What about the rest of the cooling flow? Standard practice that we have is 2.5 liters a minute a kilowatt for BitCool. That is the standard flow rate, 2.5 liters a minute for BitCool. So when you overclock 40%, are you really just going to increase the heat, or are you actually using a lot more electricity in that process that we have to take advantage of? And so we'll show you that in just a minute. Also, factor in PSU efficiencies, and this is a big one, and I have a slide on this that I want to show you to make sure that you're accounting for that extra heat being generated by the losses in the PSU. Piping and pumps. These are expensive to scale, meaning that if you don't plan ahead, you could go out and build all of that in place and then find out that you didn't build enough for your next stage. Oftentimes, what we will tell people is it is easy to scale tanks, fluid, even dry coolers, but it's very difficult to go back, tear out, and rebuild piping and pumps. So my recommendation is always know where you're headed. How much power do you have? What's going to be the utilization of that? And then let's plan around what the total volume of miners, given your overclocking requirements, will be. Let's design your piping and plumbing system and your pump system so that we have the right flow. And then at that point, you can make some decisions. A, do you want to put in all the pumps up front, or do we want to leave spots in the system for pumps? I know this sounds very pedantic, very boring, but I'll tell you, when you show up and it's another $500,000 because you didn't plan ahead, it can be very expensive, particularly in lead times. Pump lead times are increasing dramatically as well. Again, we've solved the problem on the dry cooler, getting that back down to about 14 weeks. But for pumps, we're starting to see those stretch out as well, particularly large ones in the 25, 30, 40, and 50 horsepower for very large systems. The smaller pumps are actually a lot easier to find. We don't see a problem there. But definitely on the larger pumps, it always pays to plan ahead. And finally, automation versus manual control. We can automate everything. The question is can you afford it, and is it necessary day one, or is this an area where you can add on? So this, again, is one of those consultative sales where you sit down and you find out really what you're going to do. It doesn't make sense to spend a huge amount of money on automation only to find out that a couple of valves will get you exactly what you need at a much lower cost. So this is kind of a typical slick system. I'm sure you guys have all seen these diagrams before. It's a 3-tank high, 2-tank wide, single manifold system. This is a 360 S19 miners. Overclock this at 140%. You're basically pulling about 1.5 meg in total electricity utilization. Not a problem. The question is how much space does it take up? Because funny enough, people don't have a good idea of what the physical space requirements are for these types of systems. Come see us. We'll sit down. We'll help you see actually what it looks like. This is a great example. This is the perfect spacing. If you had an infinite amount of space, this is what we would recommend. Dry coolers. It's location, location, and ambient temp. Meaning, location, where are you physically located? That will determine your ambient air temperature, and then the location of where you place the dry cooler and how close you place it to other equipment. That has a huge impact on their efficiency. And finally, overclocking versus power utilization. This is probably one of the most important graphs, and if you don't take a photo of this, you're missing a huge opportunity of a lot of free research. Okay? Right here, if we overclock, right, 130%, what's our power utilization? You're using a lot more power than you realize, and that power has to be dissipated as heat. This is probably the biggest design flaw that I see in so many of our immersion systems that we see with our competitors and folks that have no experience. They underestimate the inefficiency of the power supplies, and they underestimate the fact that that inefficiency creates more heat. And if you don't account for that in your system, you're going to end up with a system that is inefficient and ineffective and incapable of meeting the financial model that you sold your investors. So you can do this yourself, or you can come see us. We're the experts. We've been doing this longer than everyone else. We wrote the book on how to do immersion cooling. Thank you so much.